understand it. Like I think it's mixing potions, not any potions, just like some are safe, some are not safe, and like they're mixing the potions to make something and with chemicals.
I think chemistry is mixing things in liquid.
Chemistry is a study of all of the materials that make up our bodies and the things around us. Atoms, so everything around you, including your hands, your feet, your nails, the computer that you're on, all of them made by atoms. Super, super cool. And this is what they look like for perspective. So matter is everything that takes up space in the universe. These parts of matter, these states of matter as we call them, can change in between each other. Okay, I think we're all ready to go. Marvelous. So your cornstarch, now in your little fun, little funky, fresh bowl, you're gonna take some water and you're gonna mix with a spoon, with a fork, whatever you got. So now that you're touching it with your hands, I feel like you can give me better observation. What do you notice about it? What does it feel like, dude?
I still feel like it feels like, I feel like it's like very sticky and it's like watery.
How big?
Oh, look at my hand.
So now, this is our speaker for Friday. I hope you guys come because he's super, super cool. His name is Jose Ricardo Moreno, and he's a chemist and a biologist. So as we talked about, chemistry today is the stuff that makes up everything in the world, quite literally everything. Biology is bodies and what makes up a body and how the body works and stuff. So he is using tools that he learned in chemistry, that he used in chemistry, in order to look at like stuff inside cells and see how they're made up, and just fun times. He's cutting open cells, which is also really cool. He also made like new molecules to treat lung cancer cells, which is that's insane. That is just like no words can describe how flabbergasted I am. That is so cool. So yeah, he does a lot of chemical stuff with a lot of biology stuff, a lot of cell stuff, which is really, really cool.
Very good. So chemists are people like you and me. So whenever we're doing chemistry of this kind, just as you said, we're wearing protective equipment and we're working in specialized areas in our laboratory. I do chemistry to explore new parts of the world, and I essentially think of the world as a big coloring book. And it's an empty coloring book, and I'm able to color it with all kinds of chemicals. And on the furthest right-hand side, we see these balls of red with some smaller balls inside of blue. What that is cells coloring the actin, or the parts of the inside of the cell that bind it together. And that blue part holds all the genetic information that tells the cell how it's going to work and how it's going to function. So by choosing different kinds of colors, we're able to explore and see different kinds of things that are happening inside the cell. We're able to see if there's damage in the eye, and we're also able to color fabrics. So chemistry can be done in so many different kinds of ways. What I wanted to do with my research is to use this color pigment green called green 8 that can be found in tattoo ink, and use that to highlight cancer cells. So one of the first reactions that I did was turning this pyrene ring with the nitrogen here, and I added sulfonic chlorides here. So I added some sulfurs and some oxygens and some chlorides at 1, 2, 3. So we made some great observations that we see the color coming off here from the green. We also see this magenta, pink, purple color. And we have to also, I'm gonna make this note that not everyone sees colors in the same way. What do we see here when we look at the leaf?
I noticed that it isn't like completely green. There are some blotches, but there are also some clear parts and some round parts.
But right here, there are some ridges that define the cell walls. So unlike our cells that are not double-celled with cell membranes, Their plant cells have cell walls. So you can see them here, and they also like to take in a lot of water. So the first thing we're going to do for our activity is that I gathered up some spinach leaves, and we're going to collect a sample of those spinach leaves. So this is when I ground it up and I added some solvent to it, like acetone or ethanol to it. And you can see the liquid that's collected there, which is a very different color than just water. At this next step, we're going to take out the pigments, and I've now removed it. And we can see now that the pigment is dissolved with the green pigment. What we're going to do with this is that we're going to take out some special paper called chromatography paper. And we're going to draw a line at the bottom, and we're going to paint our pigments down there. And this chromatography paper allows us to start letting things crawl up the paper and start separating by how well the pigments are binding with the paper and with the liquid that's inside that's carrying up from the top. And we'll be able to see this in a moment. Now at this point, I want to ask, how many colors do we think that we're going to find inside of that pigment?
3 different colors. One is green, and I think there's sort of like a little bit yellow that's mixed in with the green to make it that kind of.
Nicole's saying that there might be only one color, and I see that David says that there might be 3 colors.